Okay, so next it says, sometimes a compound inequality joined by the word and can be written as a three-part inequality. For example, 5 is less than negative 2x plus 7, and the same thing, negative 2x plus 7 is less than or equal to 11, can more concisely be written as 5 is less than negative 2x plus 7, and that's less than or equal to 11. So what you could do if you wanted to solve this is you could break it apart into the two inequalities that made up the three-part inequality and solve it like we did on example 4, considering that word and in between there. That's one way to do it. But the most efficient way to solve a three-part inequality is to isolate the x in the middle of it, if at all possible. Okay? So on example 5, we're going to see that our goal here is going to be to do some algebra moves to all three parts of this inequality so that we isolate that x. Now, to get that accomplished, the first thing I'm going to do is clear out the fraction. All right, so to get that done, I'm going to multiply the middle by 3. I'm going to multiply over here on the left by 3, and I also have to multiply on the right by 3. On the left part of it, 3 times negative 2 is negative 6. Bring down the less than or equal to. In the middle, the 3's will reduce. What's remaining is 4x minus 1. Bring down the next inequality symbol, which is less than or equal to. 5 times 3 is 15. Okay, next let's add 1. There, and there. Negative 6 plus 1 is a negative 5. 4x minus 1 plus 1 just leaves us with 4x in the middle. 15 plus 1 is 16. The next step to isolate the x in the middle is to divide everything through by 4. Now, I'm just dividing through by positive 4, so the less than or equal to symbols, those aren't going to change. Divide by 4 on all three parts. Okay? So now we have negative 5/4 is less than or equal to x. Let's pause there for a minute. Another way to read that is x is greater than or equal to negative 5/4. Keep that in mind. And at the same time, x is less than or equal to 16 divided by 4 is 4. Okay, so if you cover up each end of this inequality, it says x values are going to be greater than or equal to negative 5/4, and x is less than or equal to 4. What that tells you is, like with the glucose range, anything in between and including negative 5/4 up to 4 is in our solution set. So when we go to graph our solution set, I'm going to put those two values on there. Negative 5/4, that's the same thing as negative 1 1/4. 4 can go over here. Okay, so check me out. I'm going to shade in values of x that are greater than or equal to negative 5/4, bracket at negative 5/4, and stuff that's greater than that would lie this way and on, but at the same time, x is less than or equal to 4. So another bracket at the 4, and stuff that's less than the 4 falls back to the left. Okay, but for it to satisfy the entire inequality, those values for x have to stay in between negative 5/4 and 4. That's the graph of that inequality. And again, feel free to check some values inside here if you want. Show that when you plug those back into your original inequality that they would work. And then also, just to show that it doesn't satisfy both parts or all parts of this, you might want to check 5 and show that it doesn't work. Or like a -2 and show that it doesn't work when you put that back in. If you want to pause the video and do that, you sure can. Okay, but my graph is what I have up here in, whoa, I didn't mean to move that. I'll just leave those little purple marks in there. Okay? The graph of my solution set is all these things in between and including -5/4 up to and including 4. Okay, so now we're saying my solution set is this compound inequality down here. And so if you're going to write your solution set in set builder notation, it'll look a little something like this. The set of all x values such that, and you write exactly what you have in there. -5/4 is less than or equal to x, but at the same time x is less than or equal to +4. Now, that's set builder notation. In interval notation, we're going to read our number line from left to right. Nothing's going on until we hit this bracket at the -5/4, comma, and then we have action occurring until we get up to the 4 with a bracket next to it. Okay? So these things mean the same, okay? It's set builder notation and interval notation. It's just a different way to express that. Now, when you have some type of interval that has brackets on both ends, we call that a closed interval. Just FYI.